This is 4.3 homework on annuities. And so here it says, suppose you would like to save for your child's college. If you are a planner, then you will start a college fund when your child is born by putting $100 in it a month. If the fund has a nominal interest rate of 9% compounded monthly, then how much will be in there when your child goes to college in 18 years? All right, so this is on the annuity section, so I know I'm going to have to use the annuity formula. And so if you look on the formula sheet, I'll tell you that's FV equals P times N over I times 1 plus I over N to the NT minus 1. So once we have the formula written down, the idea is to try to fill in each of the letters. All right, so we look here and we say, okay, FV. Do I know FV? Well, at first, I don't feel like I don't see anything that could represent FV. For a payment P, right? So this is my monthly payment because I'm compounding it monthly, and that's $100. So I have 100. And then times N is the number of times I compound interest, so that's 12. And then I is the interest rate, so that's 0.09. And I have it times 1 plus I is 0.09. N is 12. Raised to the 12 times T. So I look in the problem, T is the time in years, and it's going to be 18 years. I'm going to put $100 away each month for 18 years, and then minus 1. And so I can take out my calculator, and I can just crunch this number. So I have 100 times 12 divided by 0.09, left parenthesis, 1 plus 0.09 divided by 12, and then raised to, now remember, if I'm going to do 12 times 18, I have to put this in parentheses, so left parenthesis, 12 times 18, so my calculator knows this is all up in the exponent, then in parenthesis, minus 1, in parenthesis, enter, and out pops my answer. I'll have approximately $53,635.17 in that account. Okay, so the next question, let's look at it. It says you are not a planner. Okay, so you haven't saved any money. Your child has just turned 12, and you have realized that you need to start saving for college. You figure you need to save about $30,000 for it. Unfortunately, you have nothing saved, so you're starting from scratch. If you have found a college fund with a nominal interest rate of 7.5% compounded monthly, then how much do you need to invest each month? All right, so let's underline some numbers here. You're 12. You need $30,000. You've saved nothing. A fund with a nominal interest rate of 7.5%, again compounded monthly. How much do you need to invest each month? So again, copy down the formula. So I have FV equals P times N over I, all times 1 plus I over N to the NT minus 1, and try to plug in. So future value, well, that's that 30,000. That's how much I want when my child goes to college at 18. And then I have a payment. And if you look around here, there's no payment, so let's just write down P, and I can change it later if I need to. Times N. N is 12. It's compounded monthly. Or again, I'm making monthly payments, so N is 12. The interest is 0.075, paying 7.5%. 1 plus 0.075 divided by 12 raised to the 12 times T. So my child has just turned 12, and I'm going to assume that they're going to go to college at 18. So that's, what, 6 years? And then minus 1. Okay, now I can't just plug it into the clear screen because my letter is right here. So I'm going to have to graph the right, graph the left, and then intersect. So hit y equals and plug this in. So I have x for my p, right, times 12, so times 12, divided by 0.075, left parenthesis, and then 1 plus 0.075 divided by 12, in parenthesis, raised to the 12 times 6, so hit left parenthesis, 12 times 6, right parenthesis, and then minus 1, right parenthesis. Hit enter. Then for y2, put in 30,000. So 30,000. So make sure you actually have 3 and 4 zeros there. Make your window. For my window, I have to think, what am I trying to find? I'm trying to find the letter P, which is a payment. It's a payment I'm going to make every month for my kid's college fund, and I want to have $30,000 in there after 6 years. So the idea is like, okay, suppose I put in nothing, so I can start at 0 for $0. And how much do I have to put in there each month? Well, let's say at most I can put in maybe $500. Right? I think 500 is definitely an upper bound for how much you can put in there. If you think 700, put 700. Right? The idea is put a reasonable amount. So I'll put 500, zoom fit, and see what happens. All right, so here's the graph. Notice it's actually a line, and when I do this, I can draw the graph here. I went from 0 to 500. Here's my line. Here's my 30,000, and then I'm going to do intersect. So I hit second trace, go down to intersect, hit it 3 times, and I get out my answer. P, my payment is approximately $331.20 a month. On part C, it says, suppose you cannot afford to put away the amount from part B. So the $331.20 a month was too much. The most you can afford is $150 a month. Fortunately, your 12-year-old is really bright and will not need a college fund. But your 5-year-old most likely will if he's anything like his father. At what age must you start his college fund to reach $30,000 by the time he is 18? Okay, so 12-year-old's cool, you don't need money. But your 5-year-old, you're in trouble, right? If he's anything like his father, he's going to need some money to go to college. And so at what age to reach $30,000 by the time he's 18? So again, it's the same formula because we're in the annuity section. So FV is equal to P times N over I, all times 1 plus I over N to the NT minus 1. And I just plug in. So FV, I need 30,000. So my future value is going to be 30,000. And it's going to equal my payment. I don't see a payment. Oh, there's a payment right there. $150. So that's the most I can afford. So $150 times N, that's 12. The interest rate's still going to be the same, 7.5%, so 0.075. Left parenthesis, 1 plus 0.075 divided by N, which is still 12. Right, raised to the 12 times, now T is what I don't know. That's at what age, so that's what you're trying to kind of find. And minus 1 in parenthesis. And so the idea behind this is graph the right, graph the left, and then intersect. So hit y equals, clear everything out, and we're going to put this in. And so what do we have? We have 150. So 150 times the 12. Oops, let's go up here. So 150 times 12 divided by 0.075, left parenthesis, then 1 plus, I'm just copying this down right here, 0.075 divided by 12, right parenthesis, and then raised to left parenthesis 12 times t, so I'll just put 12 times x in parenthesis for the exponent, minus 1, and in parenthesis to finish off the formula. Hit enter, and then put 30,000 in for y2. And then for my window, I have to ask myself this question again. What am I looking for? Well, I'm looking for t, and t is time. And so I say, okay, well, I have 0, enter, and how many years do I have? Well, my kid is 5 now, and I have 18. So let's put in, 5 to 18. So let's put in, at most, I have, 13 years, it looks like. Right? If he's 5 now, in about 13 years, he'll be 18. That sounds good. And then zoom fit. All right, so there's my formula on the right. This is actually an exponential function. And there goes my line across. So now I can draw the picture here, draw the graph here. So I went from 0 to 13. It goes up like that and over like that. And I'll hit intersect. And so I hit second trace, go down to intersect, hit enter 3 times, and out pops my answer. So T is approximately 10.85 years. And the question says, at what age must you start his college fund? So it's going to take 10.85 years for this money to grow to 30,000. So what I can do is take 18 and minus 10.85 and do this on my calculator. So on my calculator, hit second mode to get to quit and clear that. I'll take 18 and minus 10.85, hit enter, and I better start this at about when he's 7 years old. If I wait any longer, I'll be in trouble. I won't be able to save the 30,000.